Welcome to Module 2, Data Preprocessing and Exploratory Data Analysis, or EDA. In this module, we will focus on preparing raw data for analysis and uncovering insights through exploration. Data preprocessing is the foundation of any data science project, ensuring the data is clean, consistent, and ready for modeling. EDA helps us visualize trends, patterns, and anomalies in the data, providing a clear direction for analysis. By the end of this module, you'll have a strong grasp of these essential techniques. The objective of this module is to master data preprocessing and EDA techniques. We'll cover how to clean datasets by handling missing or inconsistent data, scale and normalize features for better model performance, engineer and select relevant features to improve predictions, and visualize data to identify trends, patterns, and outliers. Each technique will be illustrated with practical examples and real-world applications. Handling missing data is a crucial step in preprocessing. Missing values can distort analysis and compromise model performance. To identify missing values, we use pandas methods like "isNull" to locate null entries and "info" to summarize the data structure. Common strategies to handle missing data include deletion, where we remove rows or columns with excessive missing values, and imputation, where missing values are filled with statistical measures like mean, median, or mode. Advanced methods include using KNN or regression models for imputation, which can predict missing values based on existing data. It's important to understand the implications of each method to choose the best one for your dataset. Feature scaling and normalization are techniques to standardize data and improve the performance of machine learning models. Feature scaling, or standardization, subtracts the mean and divides by the standard deviation, ensuring all features have a mean of 0 and a standard deviation of 1. This is especially useful for algorithms like SVM, KNN, and gradient descent, which are sensitive to feature magnitudes. Normalization rescales data to a range between 0 and 1 using min-max scaling, making it suitable for bounded algorithms like neural networks. In Python, scikit-learn provides tools like "standard scalar" and "min-max scalar" to implement these techniques efficiently. Feature engineering involves creating new features from raw data to enhance model predictions. For instance, extracting the year from a date column or transforming skewed data with logarithmic or square root functions. You can also create interaction terms by combining related features. Feature selection identifies the most relevant features, using methods like chi-square tests, ANOVA, or tree-based models to calculate feature importance. Dimensionality reduction techniques like principal component analysis, or PCA, reduce feature complexity while preserving important information. These steps improve model performance and reduce computational costs. Data visualization is a powerful tool for understanding data distributions, correlations, and trends. It also helps identify outliers or anomalies that require attention. Matplotlib and sharpen are two popular Python libraries for visualization. Matplotlib offers flexible, low-level plotting, while sharpen simplifies statistical visualizations with built-in themes. Common charts include histograms to show frequency distributions, scatter plots for correlations, box plots to detect outliers, and heat maps for visualizing correlation matrices. For example, a sharpen heat map can reveal relationships between variables, guiding feature selection and engineering. Our first project is analyzing survival rates from the Titanic dataset. The goal is to clean the data, encode categorical features, and explore survival trends by variables like gender, age, and class. Steps include handling missing values in the age and embarked columns, encoding gender and passenger class into numerical variables, and visualizing survival rates using bar plots, stacked bars, and histograms. For example, we'll create a histogram with survival overlay by age to understand how age influenced survival outcomes. In the Customer Churn Analysis project, we'll study telecom data to analyze customer behavior. The goal is to preprocess missing data, encode categorical features, and identify factors contributing to customer churn. Visualizations will include churn rates by tenure, monthly charges, and services used, highlighting key patterns. We'll also use correlation analysis to identify strong predictors of churn. This project demonstrates how EDA can uncover actionable insights to reduce churn and improve customer retention. Project 3 involves exploring Airbnb data to analyze pricing trends and customer reviews. We'll start by visualizing price distributions across neighborhoods and room types. Next, we'll analyze review trends over time to understand customer preferences and detect seasonal changes. Finally, we'll identify and adjust outliers in price to refine the data for analysis. Scatter plots, box plots, and time series graphs will be used to visualize these insights effectively. The final project focuses on retail sales data to uncover trends and patterns. We'll analyze sales by product category, region, and time to identify seasonality and peak periods. Revenue and profit margins will be visualized to highlight the most profitable areas. A time series plot of monthly sales will reveal long-term trends and seasonality effects, guiding business decisions. This project combines multiple EDA techniques to provide comprehensive insights into sales performance.